Welcome back to my class in Assessment and Evaluation in Mathematics. For today, we will take up the classroom assessment process, assessing students' understanding, and in line with that, we answer two fundamental questions in assessing students' understanding. The first question is, what does it mean to assess students' understanding? And what does it mean to assess students' procedural skills? We will also take up questioning today and the three levels of questioning. The classroom assessment process, the entire classroom assessment process has 4 steps. Step 1 is understand the outcomes. Number 2 is introduce the learning. Step 3, assign learning activity. And step 4 is use cumulative assessment. We now take each of these 4 steps of the classroom assessment process one by one. First step in the classroom assessment process is understand the outcomes. This is actually an activity for the mathematics teacher. The mathematics teacher needs to have a clear understanding of the outcomes. The learning outcomes is specified or prescribed in the mathematics curriculum. The teacher, moreover, has to have a clear understanding of the outcomes that are to be achieved and the multiple ways that students can be involved in the learning process. Particularly in step 1, the teacher must be able to describe what the students need to achieve. Number 2, the teacher must collect and create samples that model the learning, what the learning looks like. That is, if the teacher will be requiring her students to submit a learning output, the teacher has to show a sample of such an output to the students. Number 3, the teacher must decide what kinds of evidence the student can produce to show that he or she has achieved the outcomes. That is, design or select assessment tasks that allow for multiple approaches. This means that the teacher has to make use of different modes of assessments that will require different tasks for the students to demonstrate their achievement and learning, and that will make use of different approaches of the students. And lastly, the teacher must select or create learning activities that will ensure students' success. So the first step again for the teacher in the classroom assessment process is understanding the outcomes. And with the understanding of the outcomes, the teacher should be able to design learning activities that will ensure the achievement of the learning outcomes by students. And achievement of the learning outcomes by students is an indication of their academic success. And in the provision of learning activities, the teacher should include as many tasks as possible and use varied assessments as possible to allow the students to make use of their different approaches or multiple approaches to demonstrate their achievement in learning and also to produce different outcomes as evidence of their learning. The second step in the classroom assessment process is introduce the learning. Once the mathematics teacher has a clear understanding of the learning outcomes and has identified the concepts and skills to be taught to the students and has also made plans as to what learning activities she will assign to the students and what outcomes of learning, evidences of learning she will require from the students have been decided by the mathematics teacher, then instruction will begin. To introduce the learning, the teacher undertakes the following activities. Number 1, the mathematics teacher discusses the outcomes and what is to be achieved. This is an explanation coming from the teacher explaining to the students what outcomes they will be expected to demonstrate or to produce and what product of learning should look like. The teacher would also make it very clear to the students what is to be achieved, the skills they should be able to learn and demonstrate, and the product of learning they should be able to produce to show that they have achieved the outcomes. And in step 2, the teacher shows samples and discusses these samples of learning outcomes with the students. That is the second activity in step 2 the teacher will undertake to introduce the learning. The third activity that the teacher should undertake to introduce the learning is that the teacher plans with students by setting criteria for success and developing timelines. This is very similar to informing the student of how they will be graded for their achievement, and in explaining how they will be graded, the teacher will state the criteria, the minimum requirements for passing and the requirements for an excellent mark for learning. And also during this phase or step 2, the teacher sets the time frame for each activity. She will explain what activities will take place at this point in time and what the students will do at another point in time. Another activity that the teacher will do to introduce the learning is that the teacher activates prior knowledge. This is to prepare the students for the lesson to be delivered soon by the teacher. So as you notice, the teacher will not go directly into the teaching or instruction. There are things to be explained first to the students to introduce the learning by instruction. The teacher has to make clear the learning outcomes, the objectives of the unit or topic, the activities that the students will undertake, the basis for how their learning will be marked or graded, and the students may be involved in deciding as to what activities may be done or assigned in the classroom for the students. And also the students may be involved for setting the criteria for grading them for their achievement. And the last activity that the teacher undertakes to introduce the learning is that the teacher provides mini lessons if required to teach or review prerequisite skills. This is usually done by most mathematics teacher to activate the prior knowledge of the students before they begin with the actual lesson. They do a review of the previous lessons that or skills that students must have a relatively good competency, because these skills and understanding of the concepts from the previous lessons are needed and will now be applied to the new lesson. And that is step 2, introduce the learning. Third step in the classroom assessment process is assign learning activity. By this time, instruction is completed. The teacher did the teaching of the mathematical concepts and she has demonstrated through instruction the new mathematical skills. Now she has to assign learning activities for the students to practice what they have just learned. And these activities may be performed by the students inside the classroom or outside of the school in the comfort of their homes. Inside the classrooms, activities may include seat works, individual seat works, or group seat works, or students may do the exercises in their workbooks or in their textbooks, and activities that may be assigned to students to be performed or to be accomplished outside of the school would include homeworks, research, and projects. After assigning the learning activity, the teacher should undertake the following activities. Number one, the teacher provides feedback and reminds students to monitor their own learning during the activity. Classroom activities and also out of the school activities are assigned to students for the students to discover their strengths and weaknesses, in particular what they have not fully understand with the lesson. And in the classroom, the students are encouraged by the mathematics teacher to ask questions so that the teacher can immediately address whatever difficulties are encountered by the students as far as the new mathematical skills taught to them are concerned. And the feedback that the teacher would give to any student should be about the particular qualities of the work. That means nothing personal should be given to the student about his work. And the teacher should also provide advice after feedback has been given to students. The teacher should provide or give an advice on how to improve their work and should avoid comparisons with other students. Comparisons in terms of skills, abilities, capabilities, and intelligence. But students may be asked to show their works, explain their works, for other students to see the differences between and among different approaches to the same problem. Because in that way, listening to others explaining their works may help students to identify which method or procedure is more efficient and effective at the same time. Also, the feedback that the mathematics teacher should provide to students should have three important elements. These three important elements of the feedback that mathematics teacher should give to her students are: number one, recognition of the desired performance evidence about the student's current understanding. And some understanding of a way to close the gap between the first two. Again, the three elements are: number one, recognition of the desired performance. Number two, students' current understanding, and number 3, a way to close the gap between the first two. Okay, in the first element, before an activity starts, the teacher would usually explain and specify clearly what they should arrive at, what the students should arrive at the end of their solution. And sometimes the mathematics teacher would actually give the answer or solution on the board. And number 2, for some students who do not arrive at the correct answer or are not able to achieve the target performance, are not able to meet what the teacher asked them, that would reflect the student's current understanding. There may be reasons why the students are not able to arrive at the correct answer, and possibly they have not fully understand the explanation of the teachers, or maybe they have committed mistakes along the process, or perhaps the students lack prior knowledge or previous knowledge, and so they are not able to cope with the new lesson. And the third element of the feedback that teachers should give to students is a way to bridge the gap between the desired, the target performance, and the current performance of the students. The teacher should now give an advice how to correct their answers, how to do it better, and how to improve their performance, which is usually through practice and perseverance. So again, the 3 elements of feedback the mathematics teacher should give to students are: number 1, recognition of desired performance, that is the target performance. Number 2, the current students' understanding. And number 3, a way to bridge the gap between the first 2 elements, between the desired performance and what the students have currently achieved, because this is the only way to raise the performance of the students from their current performance to the desired performance, which is of the highest level. The fourth and last step in the classroom assessment process is use cumulative assessment. This is now undertaken by the mathematics teacher at the end of instruction of the or teaching of the entire unit, which is composed of several topics, and each topic is about a particular mathematical concepts and or mathematical skills. After the students have had adequate practice For mastery of the new mathematical skills, the teacher will now administer cumulative assessment. Cumulative assessment is a time when students must be able to demonstrate what they have learned, what they understand, as well as how well they have achieved the learning outcomes. Cumulative assessment should reflect the outcomes and should focus on the students' understanding as well as their procedural skills. This means that in mathematics, assessment is administered to students to obtain indications or demonstrations of what they have learned, what they understand, and how well they have achieved the learning outcomes. If the learning outcomes is the students should be able to simplify algebraic expressions, then results of assessment should tell you, the mathematics teacher, how well they can simplify algebraic expressions. And there are two purposes of assessments in mathematics. The first one is to get information about the understanding of students of mathematical concepts, terms, theories, or laws. And number two, assessment is undertaken in mathematics to get information, to generate information about the level of competence of students in performing procedural skills. So in mathematics, assessment cannot completely focus on mathematical concepts. There should also be items in the assessments that would generate data about the level of confidence, the level of mastery of students of mathematical skills or procedural skills. As I mentioned earlier, assessment in mathematics are administered for assessing students' understanding. And there are two fundamental questions that mathematics teachers should know the question for. The first of these two fundamental questions is, what does it mean to assess students' understanding? And the second fundamental question that mathematics teachers should know the answer for is, what does it mean to assess students' procedural understanding? These two questions imply that there are two kinds of understanding that students of mathematics should demonstrate at the end of learning. The first one is understanding of the mathematical concepts, the mathematical terminologies, the mathematical theorems and laws and properties. The second type of understanding is understanding of the process, the solution process, because solution Problems in mathematics involves several steps in a process, and these are procedural skills that students should be able to apply to solve problems, and students would not be able to apply them correctly if they have weak understanding of the process. Answer the first fundamental question when assessing students' understanding. And mathematics teacher should know the answer to this question. What does it mean to assess students' understanding? Now, there are many ways for students to provide evidences of their understanding. And mathematics teacher can also assign different tasks, the performance of which will enable the students to demonstrate their understanding. And these are some of the tasks that the teacher may assign to students. Number 1, identify and generate examples and non-examples of concepts in any representation. That means the students may be asked to identify and generate examples and non-examples of mathematical concepts in terms of concrete objects in different contexts, a verbal description of the mathematical concepts, a pictorial representation of the mathematical concept, or symbolic representation of mathematical concept. Another way for the mathematics teacher to assess students' understanding is to ask them to translate from one representation of a concept to another. Other ways for the teacher to get information from the students that will serve as evidence of their understanding is a discourse in the classroom, which is imperative or important. And in this discourse, the dialogue between and among students, between teacher and the students, should be thoughtful, reflective, and focused in order to evoke and explore understanding. And all the students should have an opportunity to think and express their ideas. And a common way for assessing students' understanding is for the mathematics teacher to ask questions. And later on, we will discuss the 3 levels of questioning. But the questions that mathematics teacher should ask must require thought, not simply requiring the students to recall a definition, to recite a definition as they have memorized it from the book. And in answering these questions, as well as in a discourse or dialogue, the wait time must be long enough for the students to think about the question, or for the students to think about her or his response to a claim or a question in a dialogue. Now, the teacher in assessing students' understanding must recognize various meanings and interpretations of concepts. And the teacher, mathematics teacher, must be able to identify properties and common misconceptions. And the students should be asked or given tasks that will allow them to connect, compare, and contrast with other concepts. But most important of all, teacher should provide students with opportunities to apply concepts in new and complex situations. This is now where the transfer of knowledge, skills, and understanding would be very relevant and useful. And it is said that true learning occurs, or true learning, relevant learning, meaningful learning is achieved by students if they are able to transfer what they have learned to a different context, to a new situation, even to their own situation, in their own community, and sometimes in a complex situation. Now answer the second fundamental question when assessing students' understanding. We now know that there are two types of understanding that should be assessed by mathematics teacher: assessment of understanding of mathematical concepts, terminologies, theories, principles, laws, and understanding of a process that involves application of procedural skills. And what does it mean to assess students' procedural skills? To assess students' procedural skills, the following tasks may be asked from students by the teacher. Number one, students should be asked to provide evidence that they can recognize when a procedure is appropriate. And the students should provide evidence that they can give reasons for steps in a procedure. Students should be able to reliably and efficiently execute procedures. Students should be able to verify results of procedures either analytically or by using models. And students recognize correct and incorrect procedures. These are the things that the teacher, mathematics teacher, should be looking for when assessing students' procedural skills. She should check if the students can recognize when a procedure is appropriate, whether the students can give reasons for steps in a procedure. 3. Whether the students can reliably and efficiently execute procedures. 4. The students, can they verify results of procedures either analytically or using models? And the teacher should check if students can recognize correct and incorrect procedures. Questioning. Questioning can be used by mathematics teacher both as a means to assess students' understanding and as a way by which students can learn more. It is said that effective questioning can result or may result in more student learning than any other single technique used by educators. And for this to happen, the mathematics teacher should plan ahead of time what kinds of questions she want to ask. And the important point to remember by mathematics teacher is to never ask questions that are answerable only by either yes or no. There are 3 levels of questioning. The first level is the knowledge level. The knowledge level is the first and the lowest level of questioning. Questions written at the knowledge level require students to simply recall specific information. However, recall questions or questions that require students to recall information are necessary at the beginning because critical thinking begins with data or facts. And there are also times when students have to remember factual information and they should be able to repeat what they have learned. Questions at the knowledge level make use of the following keywords. If you find any of these keywords in a question, then you are most certain that that question is a question at the knowledge level. And the complexity of the questions asked at the knowledge level is described as low. And these are the keywords that frequently used in questions at the knowledge level. Number 1, identify. Number 2, compute. Number 3, recall. 4, recognize. 5, find. 6, evaluate. 7, use. And 8, measure. Level 1 questions rely heavily on recall and recognition. The questions typically specify, as suggested by the keywords, what the students should do. At times, the student must carry out some procedure that can be performed mechanically, and the student does not need an original method of solution. And questioning at the knowledge level may make the students perform or do the following. Questions at the knowledge level will make the students do or perform the following. Number 1, recall or recognize a fact, term, or property. Number 2, recognize an example of a mathematical concept. 3, compute a sum, difference, product, or quotient. 4, recognize an equivalent representation. 5, perform a specified procedure. 6, evaluate an expression in an equation or formula for a given variable. 7, solve a one-step word problem. 8, retrieve information from graph, table, or figure. This is just simply obtaining a single information being asked from the question from the given graph, table, or figure. And these are the, if students can do this, these would be evidences of understanding of students at the knowledge level. The second level of questioning is the comprehension level. The complexity of understanding of students who answer questions at the comprehension level correctly is described as moderate. And as I said earlier, the complexity of understanding of students who are able to answer questions at the knowledge level is described as low. In comprehension level, the questions asked usually contain the following keywords, and these keywords would tell what the students should be able to demonstrate. Number 1, these are the keywords. Number 1, used in questions at comprehension level. 1, classify. 2, organize. 3, estimate. 4, explain. 5, interpret. And 6, compare. If you see any of these keywords in a question asked by a mathematics teacher, then you are most certain that that question is used by the mathematics teacher to assess the understanding of students at the comprehension level. Questions asked at the comprehension level give students more flexibility of thinking and choice. Questions asked at the comprehension level require a response that goes beyond simple recall, beyond the habitual and mechanical. And usually, the method of solution is not specified in the question. The questions ordinarily have more than a single step, and the student is expected to decide what to do using informal methods of reasoning and problem-solving strategies. The student also is expected to bring together skills and knowledge from previous learning experiences and from various domains. The following illustrate what the students would do when asked questions at the comprehension level, and the requirement from the students, the performance required from the students at the comprehension level is of moderate complexity. Questions at the comprehension level will require the students to do the following. Number 1, make connections between facts, terms, properties, or operations. Number 2, represent a situation mathematically in more than one way. Number 3, select and use different representations depending on situation and purpose. 4, solve a word problem involving multiple steps. 5, compare figures or statements. 6, explain and provide justification for steps in a solution process. 7, interpret a visual representation. Next is extend a pattern and retrieve information from a graph, a table or figure, and use it to solve a problem that requires multiple steps. Other questions at the comprehension level may make students to formulate a routine problem given the data and the conditions. And lastly, students may be required to interpret a simple argument. The third and last level of questioning in mathematics is used to assess students' understanding of applications and problem solving and evidences of learning, the complexity of learning demonstrated by students at this level of questioning is described as high. And the following are the keywords that are usually used in questioning at the third level. Number 1, analyze. Number 2, investigate. 3, formulate. 4, prove. 5, explain. And 6, describe. Questions at the third level make heavy demands on students because the students are engaged in more complex activities. In particular, answering questions at the third level of questioning will make students engage in reasoning, planning, analysis, judgment, and creative thought because the students must think in an abstract and sophisticated way. Questions asked at the highest level of questioning for assessing understanding of applications and problem solving will make the students do the following, and these performances are described as high in complexity. Number 1, explain relations among facts, terms, properties, or operations. 2, describe how different representations can be used for different purposes. 3, perform a procedure having multiple steps and involving many points at which the students have to make decision at each point. 4, analyze similarities and differences between procedures and concepts. 5, generalize a pattern. 6, formulate an original problem. Next, solve a novel problem. Next, justify a solution to a problem. Next, describe, compare, and contrast solution methods. Another one, formulate a mathematical model for a complex situation. Next, analyze the assumptions made in a mathematical model. Next, analyze or produce a deductive argument. And provide a mathematical justifications. We will now have examples of questions and learning activities for each level of questioning. This is one sample question at level 1 or knowledge level. One asks when 2x plus 3y minus 12 equals 0 is graph, y-intercept will be a 4, b negative 12, c negative 4, d 6. Numbers 2, 3 up to number 8 are samples of questions at the knowledge level or level 1. These are examples or samples of questions at the comprehension level or level 2. One example of a question at level 3. These are two more examples of questions at level 3.